Hello everyone. So today we'll look into the Puma 560 manipulator's forward kinematics and how to go about it in Corke Toolbox. So what we initially did was we fed in the DH tables values inside the Corke Toolbox and we got a nice Puma 560 plotted inside the workspace of our Corke Toolbox. So just to remind you again, I'll just run it again. And so here is the fine, nice Puma 560 plotted. So the rules now are really simple and it's pretty easy to do. So as you know that in forward kinematics, all you need is the joint angle values. Those joint angle values will give you the final location of the manipulator's end effector and its orientation as well. So let's say we define the angles as Q matrix and we feed in all the values. So values will just initially start with the zero angles and I'll put all the six angles as zero. Okay, those are our six angles. Now once we do that, we write Puma, that is the name of the manipulator which we initially wrote, that is Puma.serial link L, right? We wrote it initially like that. So we do Puma that dot FKINE, that is forward kinematics, and we feed in the angles. Now angles is the value which we stored as Q over here. Okay, and once I press enter, I'll get a DH matrix. That is what we actually get when we do mathematically also, right? And we know that the matrix last column tells you the position, that is the X, Y, and Z positions of the end effector. So to validate this, we'll do puma.teach. I have told you about .teach function in the earlier videos. Do have a look at the same if you are not aware of it. So once I do that, I get the angles along with the position. So we can verify it like if I have angle 0, 0, 0, 0, the original values which come are 0.52 minus 0.15, 0.43. And to check if our forward kinematics is doing the same thing, yes, we are getting exactly those angles and positions. So I think this is a good one. Now let's verify with some other angles. So we'll do Q equals to, now we'll do the third one as pi by 2, that is 90 degrees, and the last one. Okay. And do Puma FKIN again. Okay, now our angles are this. And once we run puma.teach, we'll feed in the third angle and the last angle is 90 and see. Perfect. We're getting a 0.008, that is 0.001, that's almost similar, and minus 0.15 and 0.020. So here the values are much rounded, that is why we are getting 0.001, but this is all about it. I think you have a clear picture now. Do let me know if you need some other manipulators forward kinematics and I can show you that as well. Thank you for being hooked till here. Um, have a nice day. Robometrics.